This is Modern Data Architecture. My name is Hestia, and your host and your co-host is Apurva. Please be mindful of our COVID regulations and keep your mask on. Also silence your phone during the session. Don't hesitate to raise your hand. If you have any questions, the session is currently streaming via Zoom, and it will be recorded and will be available in a few weeks. Today, we have our guest, Sonny Khan, Senior Data Specialist at AWS. He supports the Southeast region customer of AWS Analytics Services. He's here today to talk to us about modern data strategy made possible by AWS Data. Without further ado, I'll hand this over to the speaker. Thanks for being here.
Thank you. Let me get this situated here. We have a couple of fun things we're doing with our technology stack, but it's part and parcel of it. All right. Welcome, everybody. My name is Sonny Khan. As I mentioned earlier, I work for AWS. I support the data for Southeast region of the United States for data analytics. My team supports some of the largest customers for data analytics consumption on AWS and across the country as well. Customers like Zendesk and VMware and others as well. I am a Florida native, so I've flown all the way across the country to be with you guys today. My wife is an LA native, so I'm not too far from home. I also still have my 408 phone number from back when I started my first startup in San Francisco, so at home in California. And that's my contact information if you want to reach out to me on Twitter or LinkedIn. And then today we're going to spend about 40 minutes talking about modern data strategies and how to implement them and why they're important. So we'll get started. Okay, there you go. Sorry, just trying to do the arrows. So I think everybody here understands, and part of the reason you're at DataCon LA today is because you realize that the number of data sources out there are growing significantly. They're growing significantly. You've got telemetry data coming in, IoT devices, you've got social media feeds creating all kinds of data. So, sort of the number of data sources has kind of taken off, and it's ever increasing. And our customers keep coming up with new ways to consume new data sources. So I think that's understood. You couple that with the fact that the scale of the data has also increased. Yes, go ahead. So I will try to have 10 minutes at the end for questions, but go ahead.
It wasn't a question, just that thing was blocking your slide. Something was blocking your slide. It's okay now.
It's good now? All right, thank you. Appreciate that type of question. Yeah, so as I was saying, the size of data has grown, right? So this number of 448 zettabytes is a little hard to kind of ingest and think about. But an easy visualization would be if you were to take a hard disk with 1 terabyte on it, stack it on top of each other, you'll basically end up getting about going the height of the Eiffel Tower about 20 million times. And that is a very slow animation. I hope it doesn't go as slow as it's showing here on my screen. Let me hit escape and jump to the next slide, because that is not going to work. Okay, so just to give you an idea around some of those numbers, I know it's about 20 million times the height of the Eiffel Tower, right? That's a lot of data we're talking about. We at AWS think that the data is kind of reaching a tipping point where doing your data analytics and managing your data sets on-prem is becoming harder and harder, and especially becoming a data-driven organization is very important to whatever business you're running So let's talk about some of that as well in depth. We know that data-driven organizations average about 30% annually additional growth, and this is from a Forrester research. You look at an Accenture research, you've got about 68% of organizations that are basically going out there saying, we're unable to realize value from our data, and 28% of them don't even have any kind of data strategy in place. So we know there's a gap. We know that there's a desire for folks to kind of get to the next phase. Let's also look at what happens for companies that are able to realize their data strategies and derive value from their data. So on average, there's a Forbes research that says that there's $65 million net increase for businesses that are able to derive, become more data-driven and make decisions based on data. On top of that, over a 5-year period, you're looking at a 415% return on investment. And then you're not spending more money to get to that either. You're actually seeing a overall reduction in overall total cost of ownership, and that's about 48%. So those are some significant numbers that can't be ignored if you're a modern data organization. So where do you start? How do you become a modern data an organization that's implementing the modern data strategy, right? So you can pretty much start anywhere, right? There's 3 pillars. Modernize, unify. These graphics are extremely slow. They're not this slow on PowerPoint. So the 3 pillars are modernize, innovate, and unify. And you can pretty much start anywhere. You can also start in parallel in any one of these. And today what we're going to do is we're going to dig a little bit deeper into these and see what some of those mean in action and how you can implement them on AWS Cloud. So from a modernized perspective, what we're talking about here really is focusing a little bit more on legacy data stores, legacy data warehouses that are potentially holding you back because there's a lot more sort of overhead in terms of managing some of the work associated with hosting them on-prem. There's undifferentiated heavy lifting, as we like to call it at AWS. It's, you've got data administration on those databases. You're potentially trying to handle a lot of stuff that's not adding value to your bottom line. And so modernizing some of that can get you to a point where you can start seeing value. Then unifying is the other sort of pillar. You may have ways to manage this data, but is it really sort of coming together, right? If you've got a set of data sitting somewhere else and a correlated a data set that needs to be correlated for you to make decisions, but it's siloed and you can't look at it together, you'll again run into problems. So unifying some of that data is absolutely critical. Now, once you've scaled, once you've taken care of scale and the different types of data sets, you've got data unified and it's no longer in silos and through security and access controls and governance, you've sort of found ways to combine the data. That's when you truly start innovating and you're able to make some data-driven decisions and get to the next stage where you're able to make sort of data-driven decisions, use machine learning, artificial intelligence to kind of get to the next, get to your business outcomes and derive value a lot faster. So before we jump into some of this in action, right, let's dig a little bit deeper into each one of these. So I think I mentioned the overhead associated with your legacy systems, but more importantly, we need to kind of modernize and with the new purpose-built AWS services, cloud-based AWS database relational or otherwise services, you tend to kind of see a more purpose-built approach, and you'll see this theme across AWS. One of the things that we believe in is that purpose-built tools give you the capabilities to do what you need to, and we try to make sure that you can work across data sets as well to get there. But if you were to kind of take the opposite approach of a one-size-fits-all tool, there's always a trade-off. You always lose something or you always give up on something, and so it's always harder to kind of keep up with things. So from that perspective, we believe in purpose-built tools, the right tool for the right job. Additionally, the other concept of modernize is to handle structured, unstructured, and streaming data. Anybody here know what unstructured data would be? Could anybody shout out an example? Just go ahead and shout it out. Yep, both good examples. So text, video, audio, those are good examples of data. Now you can't ignore that data. If you've got audio data sitting somewhere, you've got to be able to extract value out of that. And so being able to kind of modernize where you can process structured data, unstructured data, and semi-structured data, right? So a lot of your web pages produce a lot of semi-structured data that's not, it has some structure, but it's not completely structured where it's like a database and you can start doing SQL queries on it. So being able to process all 3 types is very important, and that's part of the modernization in terms of data strategies. And then last but not least, you cannot ignore machine learning, AI, ML. They're sort of the big buzzword that everybody keeps talking about, but being able to provide the infrastructure so that you can go from months to days in terms of realizing value and speeding some of that up by removing undifferentiated and heavy lifting associated with that. Let's see, next slide. So we talk a little bit, let's switch to unify data. Sorry, I've got two laptops. I have to change slides on both, and one of them seems to be a little bit slow for some reason. So one of the big things about with removing data silos, right? So if you've got different data sets already, you've got streaming data coming in from your factory telemetry devices, IoT devices, you've got sales data sitting there. How do you correlate that, right? Like, how do you correlate data to say that, okay, in the field, I'm seeing devices break up at a certain speed and time. And by the way, when I look at the factory data when it was produced, the moisture content in the factory is causing some of those issues, right? In order to find those correlations and improve that manufacturing process, you need to be able to remove the silos that the two data sets are sitting in. And so one of the best ways to kind of do that is to be able to put data where it belongs, bring it into the different tools, and we'll go into details in all of this, but at a high level, you need to be able to move the data around and make it available where it is. At times, you even without moving the data, being able to just access it. The other aspect of this is being able to make decisions quickly, right? So the right controls are important. We were talking in the previous session about PII data. Similarly, you've got GDPR and other regulatory compliance issues going on, depending on what sort of business you're in. Being able to give access to the right people at the right time is critical. So having governance on top of that and security, not just talking about encryption and making sure you're encrypted. Obviously, that's the first level of that job, but also being able to give the right group of people the right access when they need it, or even being able to request it because it's possible now. The last but not least, once you've unified some of this data, in order to derive real insights out of it, you need the right visualizations, the right tools to be able to do machine learning, for example, on them. So as an example, QuickSight allows you to ask questions in plain English, as opposed to sort of when you're used to your standard visualization tools, you're kind of trying to build, either using easy low code or no code ways of building new charts and diagrams. If you're familiar with Excel, that's kind of what you're doing with some of that data. But with QuickSight Q, you're able to just ask a question and say, hey, what are the sales in East for the months of April and February, right? So it's easy questions that anybody can type in a plain English and they'll be able to answer those questions. And so you see machine learning sort of going across into different areas as well as you unify your data. And then last but not least, you innovate. That's the third pillar. And again, you can do any of these in start anywhere or conduct them in parallel. So as you kind of get into the innovate phase, that's where you really start seeing some additional use cases that help you with your business, and you can work your way backwards from business, right? So as the types of data loads evolve, you're able to use machine learning again in very unprecedented ways. For example, fraud detection is a great example, right? So a lot of us are now used to our banks sending us text messages saying, hey, we detected some fraud. Being able to detect that pattern think about what it takes for you to get to that point. We've got to be able to predict or understand how you typically interact with your bank accounts, and then being able to detect an anomaly fast enough to be able to detect fraud and report that back to you, confirm from you, and that then reinforces the machine learning to be able to respond. Now that's kind of the innovation part of it, right? What we see customers do all kinds of interesting things when they have access to these tools, and we've provided a whole bunch of these tools that are sort of pre-trained. You don't have to train them. They, if it's sort of repeatable things that where converting audio to text, as an example, that we've got a lot of pre-trained AI/ML resources that you can start using in your innovation, and then of course you can still train your own models and manage the drift associated with them and everything else that goes with it. And the net result of this is that your customers or your end users end up sort of having greater experience, and you're closer to them as a result of the feedback loops as well. So what does that look like in action? Let's talk about that, right? This is going to be an extremely slow graphic on Keynote. I apologize for the speed of these graphics. But a modern data strategy in action looks a lot more faster than this graphic does. But you essentially have to imagine that, or stop imagining as soon as this loads. You have additional data sources. We talked about that. Being able to connect them to whatever purpose-built tools you're going to be using, that's pretty critical, being able to utilize these data sources. And we'll dig into each one of these circles in a second. Skipped it. I'm afraid of going back almost. The arrows are not working. It's actually giving me trouble with the arrows. Yeah. So yeah, this is an important graphic, so we'll just suffer through it one more time. At least keeps us awake, right? So that's good. Yeah, so being able to kind of connect more and more data sources, right? We talked about real-time data sources. We talked about sort of batch and small batch data sources and IoT devices and structured, unstructured, semi-structured data coming in. So being able to connect to them, right? Because they're not always being produced in places that you would like them. They're being produced by third-party tools, applications, SaaS applications, and other plaplaces, right? I mean, we're generating right now data as we're in this conference room, from sentiment analysis to everything, right? So that being able to connect to more and more data sources. Then in the middle, you've got kind of a cyclical thing, which goes back to, making sure that you have the right tools for the right things. So, analytics, there's different types of analytics. We'll dig a little bit deeper into business intelligence, machine learning capabilities from low code, no code to pre-trained and training your models. Different types of databases. There's about 150 plus different variations of that. And then data lakes are absolutely essential to being able to unify your data sets. And then of course you need to be able to catalog all of this. Your data can be found, and then governance to make sure that it's shared in a controlled fashion. And then last but not least, as you're producing this data, making this data available to your users, applications, devices, and people, they're then creating new sets of data, which then you need to be able to connect to and feed back into the system. So let's dig a little bit deeper into it. So that diagram is a little breadcrumb on the top right, and we're going to focus on each one of those areas a little bit, right? So ingesting data from pretty much all over requires the ability to be able to pull different data sets. And I know we have a lot of services at AWS, so I'll try to point some of these out as to where what is usable. How are we doing on time? I don't see the clock on this. It's 11:07. Okay, we're good. We're good. I want to make sure you guys have enough time for questions at the end. Okay, so being able to ingest data from different sources, right? So you've got industrial equipment, digital media, and social media, online transactions, financial. You need to be able to connect to those. So you've got kind of your standard ODBC, JDBC connections into databases and being able to pull data in from that. But then another thing we're starting to see is that customers want third-party data. So you might be, you might have some good data about your users, but maybe there's somebody else who's selling a data set that helps you enhance a picture of your customer even more, sort of a customer 360 or KYC if you're in the financial industry. So AWS Data Exchange allows you to go purchase data sets. And a lot of times, if you were previously trying to do that, there was lengthy legal processes for you to purchase the data and all kinds of indemnification and payments and statement of works. But now with AWS Data Exchange, if you have an account, you can subscribe to a data set and it becomes available in Redshift or an S3 bucket, and you can start consuming it and mixing it in with your existing data sets. The other thing is ingesting and storing streaming data. You've got streaming video, streaming audio. You've got streaming data coming in from clickstream data from website usage, right? So when you log into your web portals, your social media accounts, you start seeing newsfeed, and it just keeps going every time you hit refresh. And that's real-time data coming in. So Kinesis data streams, Kinesis helps you with getting your better handle on some of those data sources. And then you've got third-party data, right? So we remember that loop we talked about where devices and they feed back into the data sources. So you've got SaaS applications that are not going away. They're going to be there, and they provide values. Those SaaS applications are, currently might have proprietary databases where data is hidden in there. So they might have data APIs exposed, but in order for you to be able to consume that data quickly and easily, something like AppFlow will help you connect with Salesforce, SAP, Zendesk, and other AWS services to be able to bring that data in quickly, because just being able to connect to those is not always enough. Sometimes you need to be able to understand their schema, their models, and then be able to ingest only the right data sets at the right time. And then something like AppFlow can also, AWS AppFlow will help you sort of bring in data as it's changing, instead of copying, I don't know, 75 terabytes of data every single time because 2 megs were added to it. So those are some ways in which we can move these data, move the data around and modernize on that. And so I mentioned something about different types of databases. So we've got about 15 plus purpose-built database engines. We'll talk about that in a subsequent slide, because each data set kind of offers different types of services, and you need the right tool again for the right job, right? So we'll dig into that. But at a high level, you have relational databases, which everybody's pretty much familiar with. Then key value databases are also pretty important. So those can sort of imagine you have a table where sort of one key is important, and then the value side of it can be much larger, and you almost always look it up based on the key. So it could be customer, it could be a product, but imagine data sets that do that. Document databases have become pretty popular, and they extend the flexibility for you to sort of add different new columns and everything on the fly, but they have their own complexity that comes with it. So you need to use it for the right job. Graph databases help you build networks, which is really sort of relationships between different data sets, entities, and specific relationships around them. Time series databases have become very popular as IoT devices become more popular, because they're typically partitioned by time, and being able to get data even milliseconds faster at times is more important. There's about 650,000, and this is probably even a bigger number than at this point, but at the time that this slide was produced, it was about 650,000 plus databases that have been migrated over using AWS Data Migration Service, which is basically a data migration service from many sources to AWS and other services as well. The other thing is that with cloud-based databases, it removes, again, your undifferentiated heavy lifting, right? So you can spin up a database engine on AWS, where you're managing a lot of it, but then there's versions of those that are fully managed, semi-managed, where you don't necessarily have to think about scaling up and down or spinning up a backup or in another region. It's just a matter of clicking it in the configuration, and it really helps you focus on your business as opposed to kind of spending time. And this really goes back to some of that total cost of ownership that we were talking about, reduction in that as well, while you're still being able to realize business value. Okay. Data lakes. Data lakes are foundational for data unification. We talked about removing silos. So while the purpose-built tools I was talking about allow you to move data, and as an example, in those purpose-built tools, let's say you have Redshift as your data warehouse, but you still have transactional data sitting in Aurora. As the transactional database data is coming in, you still need to be able, customers want to be able to use deep analytics on Redshift, but inject into it that real-time data as it's coming in, and not wait till the nightly batch drop that pulls it in. And so using something like a federated query concept, you can now combine the two data sets and get the most latest up-to-date picture. So while the purpose-built tools can talk to each other, the data lake serves as kind of a central location for you to store all kinds of data. So if you're not familiar with the concept, that the base of it is an S3 bucket, which there's so many variations of it, and then lake formation sits on top of it to give you a data lake. But an S3 bucket, as you for anybody who's kind of used it, is you can either take a dump of a database and store it in there, or you can just store an image file in there for or a text file, audio file as well. So it gives you an ability to kind of store different types of data sets in one location and really bring unification to it. Now, there are, when you open up an S3 bucket to the whole company to store data into, and you have the capabilities to store everything, you can imagine that can go that can go wild as well. So we'll talk about how to govern some of that as well. But it really gives you the ability to just pretty much store all the data in there, and it's one of the I want to be accurate on this. It's really from a durability, availability, scalability, reliability perspective, it's really not, it's unmatched. It's one of the first places where data lakes were formed. And I think most data lakes live in an AWS S3 as well. It's one of the most popular options and solutions for our customers. Well, so I mentioned you've got all this data set sitting in there. How do you get better control of it? I'm going to drink a little bit of water to keep going. All right. We'll have plenty of time with slow graphics here, so it's okay. Yeah, so from a data catalog perspective, right? So you've got all this data sitting in there. So what you use something like AWS Glue to scan that data set. AWS Glue provides you crawlers to be able to scan different data sets and be able to discover your data. So once you've got the data catalog, you know exactly where to find it. And this, again, removes some of the silos associated with that. So it can also, you can also use things like Glue to transform some of the data. Data Brew will allow you to kind of connect to a data set and be able to look at the data quality or data profile, as they call it. So now you can see if a column has null values or not. And let's say you're a data scientist, that's very beneficial for you, because all of a sudden, there's some metric, and I think a couple of years ago it used to be 80%. It's gone down to maybe 60% now. But 80 or 60% of a data scientist's time is used in cleaning up data sets before they can actually start doing training models and everything and wrangling data. So this helps you with that, because right away, without sort of running a model for 6 hours, instead of finding out there was a null value in the age field or an alphabet in there, Data Brew will help you just go through terabytes and terabytes of data and tell you if there's bad data quality in that column, and you can address some of those in your error handling, as an example. And then, of course, I mentioned catalog. So once you've cataloged the data, now the purpose-built tools have a way of knowing what's sitting in the data lake and can start processing it for additional data. And then lake formation gives you, AWS lake formation just gives you one location for you to say which groups have access to what data at a table level, a database level, schema level, or at the row level within the data. All right, let's keep going into the different aspects of the breadcrumb on the top right. So from a database perspective, and I think we spoke about this, so I'll skip through this, but essentially being able to, I better talk fast, it's gonna go off screen soon. Okay, so it gives you the ability to query data, real-time analytics, data warehouses like Redshift, big data processing like EMR, give you the ability to be able to kind of look at a lot of data sets in broad fashion. For interactive queries, you can use Athena essentially to be able to access data sets without, if you're not sure at some point, you're like, hey, I don't know if I need a data warehouse for this, or this is more big data analytics, and you need to do some kind of interactive querying for the moment. You can use something like AWS Athena. Again, you have third-party flow applications that can come in, and then Redshift is a data warehouse, of massively parallel processing capabilities within Redshift, because you have the leader nodes, you have the nodes, additional nodes that support the data warehouse, and then within the nodes you have what we call slices, which are virtual nodes. So you really have a massively parallel processing. So one easy way to think about Redshift is, if you're sort of talking to an Aurora database, you're getting a transaction, you're getting information about this gentleman sitting here on my right. But if you're using Redshift, a lot of times you're saying, well, what's the average age of the room? What is the, sort of what's the distribution of people from different zip codes in the room? And so now you're going across those columns. And so that is a lot more compute power required, and Redshift allows you to do that, not only at 3 times better price performance, but depending on sort of different data sets, but some of the common industry data sets about 10x faster in a lot of cases. The scale on Redshift, again, can go up to exabytes in terms of data warehousing as well. So from a, part of your modern data strategy, being able to use the right databases at the right time, and we give you a lot more options in that as well. Should see what kind of speed I'm getting on graphics here. Okay, so we touched upon machine learning, but let's dig a little bit deeper, right? So from a machine learning, there's multiple sort of aspects to this. Being able to get the data in, but then be able to run your machine learning workloads on it as well. So we talked about pre-trained data sets. So you have things like forecasts that can do forecast prediction in terms of your supply chain or your products. A lot of you are probably familiar with other customers, like you also bought this on our Amazon.com site, but that's sort of a prediction sentiment analysis to determine what you would also prefer. So we have a lot of pre-trained ML that can just remove some of the undifferentiated heavy lifting, and you don't have to sit there writing code and developing models. You just use those services. Now, if you're going to do something very unique to your business, let's say you're trying to predict, and this is a real use case. One of my customers was trying to predict if their customer deliveries of, can I say the product? Delivery of a certain product was going to be to arrive on time. And so as a result of that, they had very specific data sets. They wanted to make sure what the product was, what the branch name was, and then if the delivery had specific issues with it, then the machine learning would predict it. So that's a specific model they needed to train. And one of the things with models, anybody here familiar with it will know, is that they tend to drift. So over time they become wrong. So you need a lot of infrastructure in the back end to be able to keep running those models, and while new data sets are coming in, to say, okay, my model is now inaccurate. Let me pick a different variation of hypertuned version of it, and then deploy that automatically as well. That's a lot of infrastructure that's required. If you had to do that without some of the services that we offer in AWS, it's a lot of compute you're going to have to manage. It's a lot of computers. It's a lot of sort of connecting them together and the networking associated with that. So with SageMaker, we give you the capability to not just train your models, but deploy them and the machine learning ops that go with that. But more importantly, how do you democratize some of that? So we offer you services where a SageMaker Canvas is kind of a low-code, no-code tool you download and connect to your data sources, and now you can just kind of drag and drop models and kick off some training models in the back end. And again, SageMaker Autopilot and others offer these capabilities to run those in the back end. You can again do the same thing from EMR, from Redshift, where now imagine you write a SQL statement instead of Python pandas, for those of you more familiar with those. But imagine writing a SQL statement that says, hey, run a bunch of machine learning models. It creates an endpoint, and now from the data warehouse, you're able to make predictions using machine learning. So we give you all these capabilities to be able to do all these services. The thing that's hidden down there is 100,000 customers use AWS AML services to make predictions with their data. Let me see if I missed anything. I think I covered most of it. So from a service perspective, there's another slide that kind of covers a lot of the machine learning slides. So we'll wait till we get to that one. And then analytics, right? So at the end of the day, okay, you've got all this data, you've got your data engineering pipeline going on, and you've got, am I okay on time? What time is?
Almost at 15 minutes.
Okay.
18 minutes.
Okay, cool. I'll slow down a little. Okay, so enabling everybody to be able to access the data, right? So you've got your data pipeline going on. So your data engineers are happy, your data scientists are happy, you've got given them machine learning, your InfoSec regulatory risk compliance folks are happy because you've given them lake formation to be able to handle the security associated with that and give the right access to the right people. Your developers are happy, you've given them access to the right tools to be able to do different work associated with that. But then at the from the end user perspective, how do they consume stuff, right? So they're either looking at applications to consume the data or interacting with them. But another very common way for your end users to make business decisions is to look at charts and diagrams. And so making them available where they need them requires being able to embed some of those analytics, those charts and diagrams in the right place. So QuickSight gives you a great opportunity to embed those, to develop those in a broad fashion, and then being able to place it where it's needed, right? So if there's an app, instead of having them log into some place and look for a dashboard and then find the analytics they need and then climb to another place to find it, you can now start embedding those analytics right where they belong and where they need them. And so QuickSight allows you to do that, but QuickSight Q, and this was last reInvent, I believe, where natural language processing can be, again, you just ask a simple question and QuickSight, and using machine learning, it will determine what parts of that statement were metrics, facts, dimensions, and then build charts and diagrams based on that. And so even if your dashboard doesn't have something, you can just ask a question in plain English and it'll answer it using data sets. So, slide is super slow. I forgot what it says. Okay, so we discussed importance of modern data strategy. We talked about why it's important, why a lot of customers tend to fail to realize that value, and how AWS Modern Data Strategy can help you kind of bridge those gaps, modernizing, unifying, and innovating in different ways. So AWS as a cloud provider is one of the best places to do some of those things, and here's kind of another reason for doing that, right? So we discussed Athena, again, a serverless offering there, serverless SQL offering to be able to look at your data. Big data processing, you have Amazon EMR, and now we have serverless EMR recently launched as well. From operational and log analytics, we have Amazon OpenSearch services. So if you're familiar with log analytics, that's kind of OpenSearch is I think 1.0. It's an open source tool, but Amazon OpenSearch allows you to host it with the infrastructure behind it. Real-time analytics, we discussed Kinesis and MSK. MSK is managed Kafka, basically. From a business intelligence perspective, you have QuickSight, data warehousing, you have Redshift, data lakes on S3 with lake formation, and then data integration, basically your extract, transform, and load, ETL as they call it, and then being able to catalog the data that's been brought in, as well as profile that data to see what's in the data set. All of that is AWS Glue or Glue Data Brew service as well. And then I promised you a slide on the various ML offerings, right? So at the top, you've got a lot of those pre-trained ones that I was talking about. Personalized forecast, fraud, lookout, they tend to be self-explanatory. Lookout is for IoT devices and for IoT devices. Kendra is a sort of a scaled down search engine of think of OpenSearch, but a scaled down version of it. Code Guru and DevOps Guru can help you sort of, if you're a tech lead in a company and you worry about your DevOps and bad code passing through, Code Guru can help you essentially detect, use machine learning to detect bad code, stop it from going on. You have the industrial ones out there to look out for metrics on this side. Healthcare, HealthLake, Comprehend Medical, Transcribe Medical, again, out of the box pre-trained stuff for AI ML. And then at the bottom, you have some core services. Lex can give you chatbots. You have speech, vision, and text and documents. So a lot of customers want to do intelligent document processing, and having kind of a modern data strategy allows you to do that intelligent document processing. I mean, I've got a customer that has sort of fax machines and email PDF that come in, and they're all in different structure. Being able to use one of these machine learning services like Amazon TextStrack can, for example, convert that into table and other tabular format or data format, and then you use applications that on top of that to read that and process or place in order and beyond. And then we discussed some of these. So you've got SageMaker R, you've got no code with Canvas, you've got the labs, and then SageMaker has all these different additional capabilities in terms of managing your pipeline. Because the key thing after you've built your model is making sure it remains accurate, and all these services help you do that. And then at the bottom of it, obviously, all these infrastructure and all the CPU, GPU innovation we've done that we can probably have a session by itself for. So that, and then we discussed this as well, but here's the slide I promised you. So the 15 plus different data sets. So we're all familiar with our standard our relational databases, but Amazon DynamoDB gives you key value, document DB gives you the document database. For caching, you've got Elasticache. This is to, if you have an application that needs to be a lot faster, you put caching in there, and you have specific databases for caching. I'm being told I have limited time, so I do want to take a couple of questions, but I will end my slide portion of this now, and let me put up any questions in the room. Or I don't know if we can take questions online, but any questions at all? Yes, go ahead.
So what kind of resources do we need to manage our data stack in AWS?
So that's a broad question, right? Because it depends on the workloads and what services you're using. And with AWS, creating an account is fast. But what services you tend to use are driven by your use cases. You're not going to use everything, right? You're going to use let's say you created the account for a database, and whatever. If you went with a managed service for the database, obviously there's less administration, and you can focus on the front end SQL portion of it. At the same time, if you picked like a fully, something that you want to highly customize and you're managing the database, then obviously you have the DBA administrative costs on top of that. So that's kind of one small example, but that varies with a lot of it. With AWS, you do get the option of removing undifferentiated heavy lifting. So it's really up to you whether you go with a custom, the semi-managed, or the fully managed version of the service. And of course, a lot of the services have serverless options too now.
What's the thing is that you still have to set everything up?
Well,
so that's an AWS administrator.
I mean, you're putting your workloads on AWS, so there's always going to be some amount of management for that. But if you compare that with trying to train your own staff to manage hard disks, remove them.
I'm going from a hosting, so we have a different hosting environment.
Yeah.
But the advantage is with our hosting environment, somebody manages all that. But in AWS, nobody manages the environment.
We have customers who use third-party hosting if they want to remove that undifferentiated heavy lifting as well from themselves. There's our partner network allows has a lot of options in there too. All right.
Thank you, Sonny, for your presentation, and the attendees for the questions in the session. You can contact the speaker directly. If there are any further questions regarding this topic, please provide your feedback using the form. Thank you again, everyone, for joining today.